So when we reviewed square roots, we talked about how to do some basic square roots, like the square root of 16 equals 4. And the reason we said the square root of 16 equals 4 is because 4 times 4 equals 16. And the square root of 49 equals 7, and we can state that because 7 times 7 is 49, because that's how you do square roots. But what's the square root of -1? Well, some people like to say that it is -1, but that doesn't make sense because what is -1 times -1? -1 times -1 is +1, which is not the same as -1, so we can't say that the answer is -1. Some students will say, well, it must be +1 then, but for the same reason, that doesn't make sense either because 1 times 1 equals +1 and not -1, so that doesn't work either. So we have an issue, and there are times where we have to use the square roots of negative numbers. We call the square root of -1 an imaginary number. And we designate that imaginary number by a lowercase I. So anytime you see an I, that actually means the square root of -1, I for imaginary number. We need to know about imaginary numbers because even though it's an imaginary number, it does have real-world reasons, particularly in the field of electrical engineering. I don't suspect a lot of my students will be electrical engineers. However, they are using products of electrical engineering. So as you watch this video on whatever device you're using, whether it's a computer or a cell phone or whatever you're using it on in the future, those items are not possible without the use of imaginary numbers. So what we're going to focus on this chapter is going through how to simplify negative square roots, the process for doing that, and how to deal with imaginary numbers when we come across them in some of our other regular everyday problems. So on example 1, we're supposed to simplify some negative square roots or square roots of negative numbers. So the first thing we do when we try to simplify the square root of a negative number is to rewrite that negative number as the square root of -1 times the square root of that positive number. So it would have the opposite sign. And that's because -1 times 27 equals -27. So then we're going to replace the square root of -1 with the letter that it represents, which is represented by that, which is I. And then we simplify the square root of 27 like the same way you would simplify square roots. So what perfect square goes into 27? Well, perfect square that goes into 27 is 9, goes in there 3 times. Square root of 9 is 3, so that's 3, and then the I, and the square root of 3. And I would put it in that order. I would put the whole number first, and then the I, and then the square root of 3. And the reason for that is that if you try to put the number behind the I, and if you have sloppy handwriting, you might do something like this. And then what does this 3 look like? Well, it doesn't look like you're trying to take I times 3. It looks like you're trying to take I to the 3rd power, which is not the same thing as I times 3. So I would not do it that way. And even though you might see this on a multiple choice test, sometimes on a multiple choice test, they will put the I behind the square root, which is okay on multiple choice tests because you can clearly see that the I is not underneath the radical sign with perfect type. But if you get sloppy and do something like that, make the radical sign a little long, then it looks like the I is under the square root sign, and that's no good either. So I would put it in this order. Let's do part B. So again, the very first thing we're going to do is make this the product of the square root of -1 times the square root of positive 216, and replace the square root of -1 with I. Largest perfect square that goes into 216 is 36. It goes in there 6 times, and the square root of 36 is 6. So this is 6I square root of 6. When we dealt with square roots, we also dealt with rationalizing denominators. So we learned kind of a shortcut on how to rationalize the denominator by taking the denominator times itself. So the square root of 5 times the square root of 5, when you multiply that together, you get the square root of 25, which equals exactly 5. The square root of 11 times the square root of 11 would be the square root of 121, which equals exactly 11. So whatever the square root is, when you take it times itself, it's going to be exactly that number. So you can do that with any number. You could say like the square root of 2 million times the square root of 2 million is exactly 2 million, and you would be correct. So knowing that the square root times itself equals the number that's under the radical sign, what does it mean to take I times I? Well, to follow that same pattern, I stands for the square root of -1 times the square root of -1. So if a square root times itself equals that number, that means that the answer must be -1. If any square root times itself equals that number, the answer must be -1. Therefore, I times I, which is the same as I squared, must equal -1. So I squared, I'm going to put over here on this column of i's, equals -1. What about I to the third power? What does that equal? Well, I to the third power must be I times itself 3 times. And the first two i's would be I squared, and we just said that I squared equals -1. Then we got this dangling I over here, so that becomes -1 times I, or negative I. And yes, there are negative imaginary numbers. So I to the third power must equal -I. What about I to the fourth power? So that's I times itself 4 times. Any two of the i's combined together is I squared, so that's -1. And then these two i's multiplied times themselves would be another I squared, so that would be -1. And so what's -1 times -1? Well, that would be +1. So I to the fourth actually equals +1. What's I to the fifth power? Well, I to the fifth power is actually the same as I to the fourth power times another I. And I to the fourth power we just discovered equals 1, so this would be 1 times I, which is just I again. And then what's I to the sixth power? Well, I to the sixth power is I to the fourth times I to the second, and if we look at what we've done so far in the column to the right, I to the fourth power is 1, I to the second power is -1, so 1 times -1 is -1. So if you keep going, you might notice a pattern here. It goes I, -1, -I, and then 1, and then the pattern repeats itself. I, -1, so then what's the next number in the pattern? Well, that would be -I, and then I to the eighth power would have to be +1, so it keeps that same pattern. I, -1, -I, and then 1. So every fourth power of I is going to equal 1. So that means I to the 12th, that's a fourth power of I, a factor of 4 of I should say, that's equal to 1. I to the 16th would also equal 1. I to the 20th is 1, and so on. So knowing what the pattern is, we could figure out large exponents like I to the 31st power. So I to the 31st power, that's really close to I to the 32nd power, which is a 37 being a multiple of 4. So that means I to the 32nd power must be 1, but I to the 31st power is the term before that. So if we go up to I to the fourth power, the term before that is -I. So that means I to the 31st power equals -I. So knowing how to deal with powers of I, we can now simplify some multiplication questions. How would you simplify -5i times 3i? Well, you just multiply the numbers and multiply the i's. So that would be -15, and I times I is I squared. However, we just learned that I squared equals -1, and you really should not leave any power of I in your answer because you can always simplify a power of I into one of those 4 numbers in the pattern. So I'm going to replace that I squared with a -1, and then -15 times -1 is +15. So all the -5i times 3i simplifies to just the whole number 15. On the next problem, we have -square root of 6 times -square root of 15. They have not been simplified yet, so I need to simplify those by rewriting each one of those as the square root of -1. Need to put the negative on the inside, times the square root of +6. And that would be I square root of 6. And then do the same with negative 15. So that's the square root of negative 1 times the square root of positive 15. Or just I square root of positive 15. And now I can simplify it like I did over on part A. We've got I times I, which is I squared. And the square root of 6 times the square root of 15 is the square root of 90, which seems like a pretty large number. I do know I need to replace I squared with a negative 1, but I can find a perfect square that goes into 90. 9 goes in there 10 times. And the square root of 9 is 3, so this is negative 1 times 3 square root of 10, or negative 1 times 3 square root of 10 must be negative 3 square root of 10. How about equations? Yeah, you might have to think back to geometry on some of these. How do you solve an equation with an x squared in it? We're going to get that x squared by itself. So I would subtract 64 from both sides. So I would have x squared equals negative 64. And then how do you eliminate the squared part of x squared? Well, you do a square root of both sides. So I will do the square root of x squared, and that cancels out each other, leaving just x. Remember, when you square root an equation, the answer could be either positive or negative, whatever the square root of negative 64 is. And hopefully at this point you already know that if it's the square root of a negative number, it will involve an I. And then what's the square root of 64? Square root of 64 is 8. So this would be positive or negative 8i. So what I did is I skipped the step of rewriting it as the square root of negative 1 times the square root of 64 and replacing that with an I. Because if it's the square root of a negative number, the answer is going to be the square root of whatever that positive number is with an I. And then the next one. So I subtract 100 from both sides on this one. So that is 4x squared equals negative 100. And let's divide by 4 next. Don't get too anxious to square root just yet. I need to cancel out those 4's, giving us x squared equals negative 25. And now I can do my square root of both sides. So x will equal positive or negative, whatever the square root of negative 25 is. So the square root of 25 is 5, but since it's negative 25, we'll have an I.